Hello, this is a short series of presentations to assist paraglider and hang glider pilots who are studying for their BHPA pilot rating exams. This series is on meteorology. This section covers valley winds, sea breezes and wave. Valley winds, also known as mountain and valley breezes, are local winds that occur in mountainous areas. They're caused by the fact that mountains are heated by the sun and the air around them rises as the mountain surface warms. Accordingly, the effect is stronger with steep, rocky mountain faces that heat more quickly in the sun. Because the air rises away from the mountain sides, air is then drawn in from the valleys around it and it flows towards the mountains like water following a stream. Indeed, valley breezes generally follow the routes taken by water, but they travel in the opposite direction towards the mountain tops and the watersheds. When the day ends and the mountains cool, the airflow is often reversed as the winds become katabatic. In such circumstances, the airflow in the valleys tend to travel in the same direction as the water in the rivers and streams. As a free flyer descends towards the middle of the valley on a strong thermic day, these winds increase in strength and can be quite dangerous. This is especially the case where valleys constrict and the air has to speed up as it flows away from the wide, open end of the valley towards the higher mountains at the head of the valley. Pilots must be especially aware of this in alpine areas. This is a large-scale map of the Alps, showing some of the deeper valleys and the ways in which the valley breezes travel in the heat of the day. This is a smaller scale map of the area around Lorania in France. A local pilot has drawn on the typical routes taken by the local winds on a light wind day when the air is being drawn into this mountainous area. The orange area in the middle of the map shows where two valley breezes commonly meet and the air is forced upwards in what is known as convergence. Areas of convergence are manna from heaven for unpowered aircraft, as they offer wide areas of free lift and an opportunity to glide for a period without needing to turn. A sea breeze is the result of the differing capacity of land and water to retain heat and to change temperature as the result of the convective heating of the sun. Land takes on and gives up its heat more quickly than does water. This means that during the day, air rises more quickly over land than it does over the sea. Because of this, the air pressure over the coast falls as air above it rises, and air tends to flow towards this area of low pressure from the sea. Air moving towards land from the sea means that the air above drops towards the sea surface, and the area high above the coastal area of the sea tends towards being low in pressure. A cycle develops, with air moving towards the coast at low levels and away from the coast at cloud base. In free flight, pilots will often see a line of cloud developing parallel to the coast, and this bank of cloud will often creep inland as the day progresses. This sea breeze front is frequently lower than the inland cloud base. The air is more moist, having flowed in from the sea, and it tends to form dark grey wisps that dangle downward in a very characteristic way. While this is a line of free lift for paraglider and hang glider pilots, it can be a little turbulent, and once a pilot strays to the seaward side of the front or descends into the wedge of sea air travelling inland, then the sea breeze front will have killed all ground level thermal activity and the pilot's flight will often end. The ledge of lower cloud towards the left of the image on the right illustrates how the moist sea air will condense at a lower altitude and form this step in the cloud base as the sea air pushes in over land. The cloud in the top of this picture illustrates the dark wispies that are commonly a sign of a sea breeze front. Wave is the result of a rhythm of rising and falling air that can set up to the downwind side of a line of mountains when the air mass is dense and heavy. In the UK, it is commonly seen in stronger wind conditions and in the winter months when the air mass can be quite dense and stable. Wave is associated with lines of cloud that set up perpendicular to the wind direction. These cigar-shaped clouds are called lenticular clouds. Certain flying sites in the UK are frequently affected by wave. Examples are Lord's Seat in the Peak District, Weatherfell in the Dales, and the Long Mynd in Shropshire. Here's an example of lenticular clouds. They can be quite long, and they mark the top of the area where the air has been bounced upward in the same way that you see ridges of water forming downstream from a stone in the river. That concludes this section on valley winds, sea breezes, and wave. Let's conclude this series with another look at a few synoptic charts. In this chart, the key features are the large depression in the Atlantic with a series of frontal systems. Over the UK, a high pressure system is extending up from the southwest, and there would be very light winds. The tail end of the cold front over the east coast would imply that the air mass may still be quite cold, and the air could well be sufficiently unstable to allow for significant thermal activity in any sunlit areas. Given that several fronts are en route to the British Isles, it perhaps be wise to make the most of any flying conditions. In this chart, there is a warm front firmly planted down the centre of the British Isles, and the closely spaced isobars indicate reasonably fresh northwesterly winds. This is probably a wet day in Western Britain, but at this time of day, East Anglian pilots will be seeing higher clouds starting to approach from the west. In this chart, pressures are quite high over the British Isles. There are some weak frontal systems around, and the isobars are well spaced, indicating light winds. What wind there is likely to be southeasterly. This chart shows plenty of weak and occluded frontal systems surrounding the British Isles, and there is a weak low pressure system in the English Channel, suggesting light winds from the east across the country. Easterly winds are fairly dry. It probably won't rain. Out in the Alps, a cold front has just passed through, and post-cold frontal conditions often mean great thermic flying conditions. So that concludes all the syllabus for the MET section of the pilot rating exam.